I wanted to show where the system of equations comes from for the variation of parameters technique that we've seen in the section for non-homogeneous equations. Now, the good thing about variation of parameters is it works generally for linear equations. And we'll only look at second order equations, but it works generally for linear equations. The thing is we have to be a little careful with it. So if I wanted to solve this equation, general a of x times y double prime plus b of x y prime plus c of x times y equals g of x, first we need to solve the homogeneous case. Can we solve a of x y prime double prime plus b of x times y prime plus c of x times y equals 0? Now, we have to solve that using whatever methods. If it's a constant coefficient equation, we have techniques for that. If it's a Cauchy-Euler equation, we have techniques for that. If it's something else, maybe we have to be a little bit more innovative. Let's just leave it at that. Or maybe we're provided some solutions. All right, so let's assume we can solve this. And we have solutions. And let's call them y1 and y2. All right, so now what we do is we go back to the differential equation and we rewrite this differential equation. Let's rewrite so that the lead coefficient, so that the coefficient on the y double prime is 1. So let's divide through by a of x. So then y double prime plus b of x over a of x times y prime plus c of x over a of x times y is equal to g of x over a of x. Now, we can leave it like this, but it's a little messy. So what I'm going to do is I'm going to say, well, the b of x over a of x is some function of x, the c of x over a of x is some function of x, and the g of x over a of x is some function of x. And so I'll write this more generally as y double prime plus some p of x y prime plus some q of x y is equal to some f of x. Now, one thing to note, and it may not be exactly clear, but the solutions of the homogeneous equation that we had, the a of x y double prime plus b of x y prime plus c of x y equals 0, one thing to note is that y1 and y2 will also solve y double prime plus p of x y prime plus q of x y equals 0. It works. Okay, so now we have our solutions y1 and y2, and we're going to work with this form of the equation, the y double prime plus p of x y prime plus q of x y equals f of x. So now what we do at this point is we make an assumption for the y sub p. We assume that the y sub p takes the form y sub 1 times u1 of x plus y sub 2 times u sub 2, where u1 and u1 and u2 are functions of x. Now, we'll need to substitute this assumed solution into the differential equation. Well, let's find derivatives. So then yp prime applying the product rule, I'd have y1 prime u1 plus y1 u1 prime plus y2 prime u2 plus y2 u2 prime. Now, if we were to continue from this point, things are going to get really ugly, because if we think about this, we're going to have to apply the product rule 4 times to calculate the second derivative. So to simplify the issue, what we're going to do is we're going to take 2 of these pieces, 2 of these terms out. We're going to make another assumption, and it turns out it's fine, it works out in the end, but we're going to assume that the terms that I'm highlighting here, the y1 u1 prime and the y2 u2 prime, let's assume that y1 u1 prime plus y2 u2 prime is equal to 0. And so then we'll use then the form that yp prime is simply y1 prime u1 plus y2 prime u2. And let's calculate the derivative from there. So then yp double prime, again using a product rule, would then be y1 double prime u1 plus y1 prime u1 prime plus y2 double prime u2 plus y2 prime u2 prime. Okay, so now what we're going to do is we're going to take the yp prime, and the yp double prime, and we're going to use them, that assumption, we're going to substitute them into the differential equation that we had. So let's take all that information, let's substitute that into the dE, y double prime plus p of x times y prime plus q of x times y is equal to f of x. And let's see what happens. All right, so y double prime. Okay, so using the assumed yp double prime, that would be y1 double prime u1 plus y1 prime u1 prime plus y2 double prime u2 plus y2 prime u2 prime. There's the first term. Plus p of x times y prime is y1 prime u1 plus y2 prime u2 plus q of x times y, and here remember we assumed for y, the yp is y1 u1 plus y2 u2. And this is all supposed to be equal to some f of x. Now that's a mess. There's a lot of terms there, but some nice things happen here. All right, so now what I'm going to do is I'm going to do some factoring here. I'm going to take all of the terms that have just u1, not u1 primes, just u1, and I'm going to move them all together. So let's look at all the terms that have u1s. Let's see. I've got a y1 double prime u1. I have a p of x y1 prime u1, and I have a q of x y1 u1. So from those terms, I can factor out u1. I have u1 times y1 double prime plus p of x y1 prime plus q of x y1. Similarly, let's work with all of the terms that have just the u2 associated with them. So I have y2 double prime u2, I have p of x times y2 prime u2, and I have q of x times y2 u2. So I then have u2 times y2 double prime plus p of x y2 prime plus q of x y2, all being multiplied by u2. Okay, then what's left? I have plus y1 prime u1 prime plus y2 prime u2 prime, those are the only terms left over, equals f of x. And now here's where something important happens. If we remember, let me scroll back up here for a moment. If you remember, y1 and y2 also solve y double prime plus p of x times y prime plus q of x times y equals 0. So that means that y1 double prime plus p of x y1 prime plus q of x y equals 0. If we go back to our recent expression, I see that same expression. I see y1 double prime plus p of x y1 prime plus q of x y1. This must be 0. Similarly, y2 double prime plus p of x y2 plus q of x y2 prime plus q of x y2 must be 0. So both of those terms go to 0, and I'm left with just y1 prime u1 prime plus y2 prime u2 prime equals f of x. And so now that creates the system of equations that we can use to solve this method. So again, the system then becomes, remember we made an assumption earlier. We said, let's assume, and I think I assumed it in red, right? In red, we made this assumption. And from that assumption, that y1 u1 prime plus y2 u2 prime is 0. And then, with the result of that assumption, we ended up with y1 prime u1 prime plus y2 prime u2 prime equals f of x. And this becomes the system that we can then solve for u1 and y and u2 to then give us the solution for yp, which we then build the general solution from. So that's where that system comes from.